Hi, everybody. I had a question from a student who was struggling a bit on the idea of net present value and where they got the table, or not the table, but the value to use in one of the questions. And I thought they asked for a recording here. Thought I would take folks through that and where the information comes from and the table behind it for everybody understands net present value. So let me share screen here then and go over to my whiteboard. The question the student was wrestling with then in the book is we had an example where we were looking at, is an investment worth it or not? And so we had information like the investment was 20,000 and the return was 5,000 a year for 20 years. And, at 12% interest rate, should we do that or not? And so one of the conversations, of course, we got into was, well, if you don't take into account the time value of money, 5,000 a year for 20 years is certainly $100,000 or euros return compared to 20,000. It makes sense. But net present value argues, well, what's that worth in today's money? Because $5,000 a year from now is not the same as $5,000 today, or even 5,000 2 years from now is not the same as today. So if you think about it, $5,000 returned in a year from now, the first payment back of 5,000 a year from now, with inflation, you could argue at 12%, then that 5,000 is only worth 88% of a dollar, or 88% of $5,000. And if we grabbed a calculator and we took, 5,000 per year, let me just grab my calculator, 5,000 per year times 0.88, then a year, in today's money, that 5,000 1 year from now is worth $4,400 today. And then the second $5,000 I get 2 years from now, then we're talking its value is 88% of 88%, just because of the cumulative or the multiplicative effect of the math. So, 2 years from now, that's worth 77%. So if we multiply that out, 5,000 a year times 0.77, that second year is only worth $3,850. So you can start to see that after each year, this value of the 5,000 is going to be less. Plus, we got into a conversation that said, imagine in the exam having to do this type of math 20 times, it would drive you crazy. And so in the book, it talked about, well, take the 5,000 times 7.47, and that's going to do all the math for you. And so we did 5,000 times 7.47, and we said 37,350. So 20 years of paybacks for 5,000 per year. That 100,000 is worth 37,350 in today's money. And so in today's money, that's worth more than the 20,000. So yes, we would go ahead and make that payment. So student was okay with that. They said, I get it, but talk to me a little bit more about that 7.47 so I understand where that came from. So I pulled up on the internet here for us. Let me grab it here for us. I pulled up this table that does the math for us. And so, if you see here, what you look at in this table is it does all that math for you. It's called a net present value of annuities table. But down the first column in the yellow column is the number of periods, in our case, 20 years. And then across the top in blue is 12, up to 12%. So if you go down, after 1 year, so I had 0.88, it's actually 0.89. And then the second year is the 0.89 plus the roughly 0.77 gets us 1.69. So they're doing each year additively for us. So that if you come down to the intersection of 20 periods and 12%, we get 7.47. So essentially by using that one number then, let me go back here, 7.47, they've done all these 20 years for us just to make sure that the math is simple here. So student then asked the question and said, I'm assuming if I get a problem like this on the test, then they're going to have to give me whatever this number is going to be for the proper interest and the number of time periods. And my response was, I don't know officially how the question will get written, and I can't speak on behalf of ASCM, but it seems like, yes, they're going to have to give us that number so that we can do the math and that stuff. But that's how we calculate the net present value of something and where those, in our example, where those 20 periods come from. So really what we're doing, if you're a visual person, we're getting back 5,000 in the first year, 5,000 in the second year, so on and so forth, all the way to 20 years. And so what we're doing is each year we're dialing it back for the inflationary effect or the impact of the 12% and the value going down each year, so that instead of having to add up all 20 of these, the sum of all these down here in the lower left corner is this number here, and that's what they're going to have to give us on the table. So hopefully that helps you understand what net present value is, as well as where that number comes from.